Coming to the stage is Jason Schafer. Jason's now leading our new data center work group.
Thank you, Corey. So Corey said the new data center work group. It's new to some extent, but I want to see who out here has been amazed and floored by the contributions that have been made to the data center group over the past year. There are a few hands. I guess maybe you're a little easy to please. I haven't been pleased with the progress that has been made, at least on the contribution side within the data center group. But that isn't to say that work has not been underway, in progress. We've been working very hard within the data center group to change that. So Omar was talking about some things on the networking side, and he started off with the history. And I'm going to do the same. But first, a little bit of my background. I've been in data centers and mission critical for about 2 decades. I did some commissioning. I did some construction management, training program development, operations management, operations program development, and I even spent some time as a research analyst. And so the context of what I come to data center is around all of those things. Some on the design side, although I'm not a PE, but also very strongly on the operations side. And what I want to give you here is more or less kind of a state of the union of what has happened with the data center group and what to expect in the future. So the history of the data center group. You may be aware that initially the data center group was stood up by Facebook's initial contribution, which was based on their Prineville data center design. So this was the data center design specification for the Prineville data center at the time. And when that happened, when it was released, I was a research analyst, and I saw a lot of different perspectives, had my own opinion, of course, and it was very well received, and there was a lot of excitement around what to expect next. The goal at the time of the data center design group and the project overall within that group was to add to this. What could be done if you take the similar approach to what you've seen in all the other work groups, take the base specifications, figure out how they can be improved, and how it can benefit the industry as a whole. So we took a similar approach, or a similar approach was taken with the data center group. But unfortunately, not a whole lot of traction was found, and I did a lot of reflection as to why. In June of last year, Tesla open sourced their patents. And the reason they did this was because initially they thought with the patents that they were worried that if they were to share their intellectual property that they would be met with similar use or rip-offs from competitors within the gasoline industry, or the gas-powered cars, that is. And they had this worry for a while, but what they realized after the fact was that this wasn't happening. The other gasoline-powered car manufacturers were not pushing electric vehicles or zero-emission vehicles as quickly as needed to happen. So in an effort to help this, Tesla open-sourced their patents. They did not obviously open source their specific designs, but they made their patents available for use without fear of retribution if additional designs were contributed or developed in good faith. So I think if Tesla were to take a similar approach to the way that Facebook did when they started up the data center group and put the design specifications out there, I think similar things would have happened. The thought process is that, why do you hear crickets? And they're the leaders, right? Tesla is considered one of the leaders in the automobile industry right now. Facebook is considered one of the leaders when it comes to data center design and all of that. So they look to them and wonder, the industry looks to them and wonders, how does this apply to me? I'm not anywhere close to that scale. It's too fringe. What can I really do with this? And maybe even in some cases, who am I to tell them how to do it? This may be a little bit foreign in the software and the server hardware industries, but when it comes to data center design and engineering, we've still got the legacy build methods to deal with, and a lot of holding on to this thought process from many of the engineering entities in that community. And then also, who wouldn't want Facebook as a customer? So a lot of these companies that have even participated in the discussion within the data center group really look at it as a way to increase their exposure and get some of the business that's going to come out of open compute. This is to be expected, but the viewpoint is give them what they want, what we know that they want, not necessarily spend resources on research, development, and all those things on data center designs, just to find out that no, it doesn't work for them, and you don't win them as a customer. So up until this point, you might have heard me interchangeably use data center and data center design. The original name of this group, of the data center group, was the data center design group. About a year ago, I don't remember the exact date, but about a year ago, OCP changed the group, acknowledging this fact. They changed it to simply data center, and there were some migrations made within the structure of the wiki pages and IRC and the mailing lists and all of that. There were some complications with some of that. Some of the contributors with the mailing lists for the original data center design group were not moved over. Anyway, we've moved past that. So as an aside, if you were originally on the data center design list and you haven't seen emails in quite a while, they have been happening. So please sign up again for the data center group. But again, this transition to the data center group and not just data center design was really an acknowledgement from within Open Compute that the scope of the data center is broader than just the design aspect of it. So I discussed the challenges that we faced, the scopes that we're looking at, and we even thought internally. We spoke within our group and with the incubation committee and all of the other leadership within Open Compute about how do we rethink this. We were kind of at an impasse. How do we make progress? And we talked about a relaunch. But I actually don't think it's so much of a relaunch, because if we're talking about a relaunch, that, in my opinion, diminishes the contribution that Facebook has made and the importance of design, and that is not the intent of this at all. So rather than a relaunch, it's really more of a second stage ignition. And so what am I talking about here? We're talking about looking at the operational side and coming up with a better framework for where the data center group is going to go in the future, and to push it beyond the initial somewhat narrow scope. So up until this point, if you look at the data center design, I've been in a lot of different data centers, and I've looked at one-lines and drawings and all of that, and it has been relatively easy, comparatively speaking, to take a look at those things, the way data centers are designed, and identify potential single points of failure, things that you have to mitigate against, weaknesses, strengths, and all of that. It is quite literally black and white on that side. Unfortunately, the same thing hasn't been said for the operational side. Until now. So I'm very excited to have been a part of all of the work that was required to make this happen. But I want to thank Schneider Electric for this contribution, because without them, this wouldn't have happened. So there is a recently submitted, a recent submission for the data center group to look at this very thing. And there are a couple things that disappoint me about this slide. One is that these 7 pictures don't do justice at all to this contribution. And the second thing is the fact that because this is so comprehensive and just in the interest of space, Schneider's logo down there is pretty small. But understand that 100% the reason for this submission. So this particular specification outlines a framework for businesses to identify within their organization the priorities for operations that relate to their business, benchmark where they are on those priorities using this maturity model, and then developing a plan to go from where they are to where they want to be. That's the initial goal of this. Some of the byproduct advantages to this is it meets exactly what I was saying before. It finally allows for the industry to speak in common terms and not work under proprietary, closed standards for data center operations. And it allows, on the operational side, to do the similar thing that I was talking about that you could do with the design. So this is the specification, which, by the way, is available in the wiki page. It's 87 pages. 7 disciplines like you see here. I'm not sure if you can see them, but they're environmental health and safety, emergency preparedness and response, maintenance management, site management, operations, change, and quality management. So within those 7 disciplines, there are 26 additional categories to it that really, like I said, make up 87 pages. And so I welcome everyone to please take a look at this. And I mean, it is in the community review phase right now. It was literally just officially submitted for consideration within the past few days. And again, this doesn't do anywhere near the justice that this particular contribution gives. Oh, and by the way, I neglected to mention that each one of those categories has a gradient of 5 different levels in there, from ad hoc all the way through optimized, and then the criteria for achieving each of those in every one of the levels. And one final point on this is that this is not necessarily intended for every business. And by the way, it even says in the front matter of this that it is not feasible or reasonable for any organization to strive for level 5 in every single category. This is not necessarily, the intention is not for this to be a war of, who can get the better score. There's no gamer points involved with this. No PlayStation trophies or anything along those lines. It's really, again, goes back to an organization identifying within the framework of this maturity model what their priorities are, what their business objectives are, figuring out where they are, and developing a plan to take it from A to B. Another advantage to this submission is acting as the basis for the framework for additional submissions and additional contributions to the group. So one of the things that we're going to be working on today, tomorrow, during the engineering workshops, and please come join us, by the way, we'll do a recap and go through some of the meat and the content of this. It's impossible to go through the whole thing. We had about 5 hours yesterday, and we did not get through the whole thing. But we will use it as the basis for the charter of the group for the second stage ignition, and hopefully, and I'm very confident that we will, come up with and be presented with new ideas out there from the industry. One of these, so if you look in the bottom left there, the operations management, part of that is, well, the way that the data center is orchestrated. So you might call it data center orchestration. So as an example of how this particular framework can help the group identify additional potential contributions from the community, from the industry, the orchestration piece is one element of it. And to that end, I would like to invite Cole Crawford with Vapor to go over a little bit about their contribution.
Thanks, Jason. Nice to see everybody. Some of you guys know me as one of the early supporters and evangelists for OpenStack. Some of you may recognize me as the founding storage project chair for the Open Compute project, and some as the founding executive director for the project. And I can't say how much I love this community. I can't say how thankful I am to have been a part of it for as long as we've existed, and I am just floored with some of the announcements today that have happened. It's been absolutely wonderful. In 1676, a gentleman by the name of Sir Isaac Newton wrote a letter, and in that letter he said, "If I see further, it's only by standing on the shoulders of giants." And you know, this industry and what we're doing together, I think, is reapplying that philosophy over and over and over again. It's amazing to see all of the innovation that's happening. I was especially happy to know that data center was going to be purposed towards orchestration. At least one of the focuses, one of the early focuses for data center was going to be based on orchestration, because I care a lot about orchestration. I care a lot about the service and the usability of the workloads that go into our data centers. I don't know that after 20 years in the data center world that I have a distinct love for the physical infrastructure, cutting my hands and spending multiple 48-hour sessions inside of data centers interacting with IT equipment in the data centers itself. So I like things to be commoditized, and I like things to be automated, and the less I've got to get up and leave my desk and go into the data center and fix stuff, the better, I guess. So to that end, I wanted to sort of try my hand at a data center company, and talking with Jason and talking with the incubation committee team, I thought that we had kind of a neat mousetrap, though I don't really like mousetrap. I kind of like to think of it as a theme park. Mousetrap sounds like you're catching something, and theme park sounds like a fun place to visit. So to that end, Vapor.io is today contributing the open data center runtime environment. And part of what we're going to talk about today is contributed, the hardware's there. And by the way, this is a contribution that is going to be 100% contributed under the reciprocal license of OCPHL. So the Open Compute Project hardware license, there's two of them. There's a permissive license and there's a reciprocal license. And this will be reciprocal, meaning you can take this hardware, you can modify it, you can hack on it, you can do whatever you want with it, but you've got to give it back to the foundation. And I'm a big believer in that sort of philosophy where everybody gets the benefits of all of the hacking we do together as a community. So what are we building? When I said that we're standing on the shoulders of giants, what I mean by that is we are able to take all of the innovations and all of the discoveries and all of the technical capabilities that corporations have built throughout the history of this world, the history of our data-driven era, and we get to innovate on top of that stuff, and that's just a beautiful reality. DCRE is really here to help us manage our infrastructure, and not just the IT equipment, but all of the data center infrastructure, the critical environments. You've got a lot of things outside of the IT equipment that matter to you in context of your workload. And we know that we can't build this all ourselves. We're a small team, but together with an ecosystem like this ecosystem who knows how to come together and go break out into engineering workshops and talk to people and say, hey, have you thought about this? Have you thought about the security constraints of this? Have you thought about the physical constraints of this? It's through communities like this that I think the pace of innovation just really speeds up. So some of this stuff we're going to talk about today has actually been contributed. The hardware is going to be out there. I know it's in the review process right now. Some of the other things that I'm going to talk about today are yet to be contributed, but not because we don't want to contribute it. It's because we need your help to contribute it. So with that in mind, what we're sort of thinking about is we want to stop having a one-to-one relationship with our IT equipment. The high touch, high cost, now granted high value, you get out of the current out-of-band management networks that you see today. We want to sort of simplify and abstract that away. And we want to work with lots of different corporations and a lot of different entities that offer solutions offers solutions around the next generation of workload intelligence, data center automation, data center orchestration. The reality is public cloud, private cloud, managed hosting, managed cloud. All of these worlds are going to blur. The lines for this are all going to blur. We're all going to have workloads running in multiple different locations. Your hyperscale companies have multiple locations, and it's all in context. It's all supposed to work in an orchestrated way with the workload. So we have, I'm sure while I've been talking, you've been reading, and I'm not a big fan of just reading bullet points to people. But we like simplicity, and we like innovating at lower levels, because the reality is, on the hardware IT equipment side, the hardware space is, man, it's a race to be completely commoditized, and we're fans of that. But we want to offer solutions to this industry and this community that allows us to simplify the entire experience of data center orchestration and automation, looking lower into the data center than we have before. The current solutions out there today talk a lot about, or talk to the IT equipment itself. And the IT equipment and the operating system know about each other, and the operating system and the workload know about each other. But what does our IT equipment or our data center operators know about the environmentals inside of the critical environments? Well, we call this enterprise sensification, or sensification of the data center. And so we're going to, hopefully as a team, work together in context of the Open Compute Data Center project to build intelligence both southbound and northbound to our IT equipment and up to the operating system, and even beyond into these workload orchestrators. And there's lots of them, right? You've got, obviously, OpenStack. You've got Mesosphere and the Apache Mesos project, which is open source. You've got Red Hat's Atomic project. You've got Docker. There's lots of cool workload orchestration, workload automation capabilities, and we want to just expose information up to these environments so the workloads themselves and the operating systems themselves can make it more choices, or have more choices, and make better decisions about where their infrastructure is running. So we've got a couple of ways to do this. We can do this through the standard OCP debug header, and we actually have some more contributions coming to the foundation about the mid-plane board on the OCP compatible boards, the Winterfell board, for an example. And through this OCP debug header connection, we can give you remote hard set, we can give you console over serial, we can give you post error codes, and I don't know if anybody here has ever powered on a Winterfell board, but there's a flash and there's a ton of data at the very beginning, and we want to actually buffer that so you can actually later go look at it and see what that post is. And inside of your standard motherboards, we can give you an IPMB interface where you get all of the benefits of what you were doing and how you've been interacting with your environment through interfaces like IPMI. So remote power on, remote power off, power cycle, and console over serial. And to that end, this is what we've designed so far, and this is what we're contributing. On the left, you'll see a Raspberry Pi. This is the new Raspberry Pi. It's got a quad-core ARM v7, I believe, or ARM v15 socket, and Raspberry Pi there's a capability called HAT, which is hardware attached on top. And so on the right is our contribution that lives, and you can actually kind of see there's a plug that plugs directly into the Raspberry Pi, and it lives right there next to a full Linux operating system that we can harden together as a community, and then we can present really cool capabilities. And one of the things about out-of-band management networks has always been the security constraints around, okay, this out-of-band management capability is RJ45 based, and it lives, maybe potentially at the top of rack. So we thought a lot about, how can we simplify that out-of-band management network? How can we make that easier to consume, more secure, quicker and cheaper? So we actually have some contributions forthcoming that have power line communication capabilities built in. So you see the the 3 green bars. And we want the bus bar effectively, the bus bar of an open compute rack, to be that virtual cable for us. So we can traverse our entire rack of infrastructure with no wires for out-of-band communication. And then, what you see on the left is also being contributed. That's the OCP debug header board, slightly different form factor, but when we can put that on the main, on the mid-plane of a Winterfell box and attach that up to the OCP debug header, you now have armed yourself with a very robust out-of-band management solution that talks northbound over interfaces we get to build together, southbound over interfaces we get to build together, and you can start looking at your infrastructure a little bit more like cattle and a little bit less like pets. So you get sort of a low-cost, high-value environment as opposed to the high-cost, high-value environment that we get today. But this is what we're building. We're very, very excited to be working with Jason and the data center project. We have a lot of stuff to contribute over the next few months. You're going to see a lot of contributions, all released under the GPL style OCPHL-R license. And if you're interested in any of this stuff, please hop down to the engineering workshop for data center, because this is where we're going to be hacking on this stuff, and it'll be this specific community that a lot of this stuff is coming through. So I appreciate everybody's time, and I look forward to working with all of you. And here's Jason to close everything out. Thanks.
Thank you, Cole. So at the beginning of this, I talked about involvement. And I'm pretty sure every single project lead, if not other contributors, have mentioned this fact, that in order for any of this to be successful, we need involvement. We need contributions. We went over a couple major contributions that I think will be very impactful. Cole's with Vapor, as well as the data center operations maturity model. But I also want to say that the data center operations maturity model is just kind of the one piece of the puzzle. So it is mostly what many would consider facility-centric, but there's still a lot of work to be done on the IT side. We acknowledge that there's room for an IT analog for this. And to make it easy, because I know how difficult it can be to punch out the URLs and make sure that you have it all right, I have a QR code here for the wiki, and the wiki page is really the central location for all of the information that you need for the data center group. It's got the submissions under review. It's got information for the mailing list. Everything you need to know is right there. So thank you again for your time. Please join us at the work group, or at the engineering work group sessions today and tomorrow, and I will see you there. Thank you.